Here we're going to take a look at domain. So we're going to be given the function and we have to identify what is the domain and using interval notation. So there's two key things you want to keep in mind with domain. So one, your denominator cannot be equal to 0. So I don't know if you've ever seen this, but a 0 in the numerator is okay, but a 0 in the denominator is not okay. So that would be a no. Okay, so it cannot equal 0 in the denominator, but it could be negative. So that's why we're not saying anything greater than 0. It can be a negative number. And then if you have an even root, so even meaning the number here is even. If there's nothing there, that's our square root, so that counts as an even number. Then the value in the root has to be greater than or equal to 0. So it could equal 0 because the square root of 0 is 0. That is something that exists. But if it's anything less than 0, that's when we start working with I and it becomes an imaginary number. So we're thinking of domain, things that exist and things that we can see on the graph is what we're looking for with domain. Okay, so looking at the first example, I have x plus 5. So we're working with a denominator. This would be x plus 5 cannot equal 0. Okay, so since it's in the denominator, it cannot equal 0. I'm just going to solve for x here by subtracting 5 to the other side. So looking at a number line at negative 5, it cannot equal 0. So I would have an open point at negative 5, but anything bigger than negative 5 will work, and anything less than negative 5 will work. So our interval notation would be continuously anything down to negative infinity. So negative infinity, we would have a parenthesis with our infinities up to negative 5, but not including. So since it's not including negative 5, we have parentheses. And then we'll do union, and then from negative 5 up to positive infinity. So we put these parentheses when we have infinity and when it's not including that value. So negative 5, so this is saying we have a gap at negative 5 here in our number line. Okay, so that's our answer there. The next one, we have the cubed root of x plus 10. So cubed root, 3 is an odd number. So really any value can go in for x. This can be positive or negative. So this would be negative infinity up to positive infinity. Anything can go in for x. So we would do that for something like number 2, or number 8 is another example. Anything can go in for x here. So as soon as you see there's nothing with a denominator or an even root, it's a pretty easy answer for that. This one is a square root. So that is an even root, square root. So x plus 5 has to be greater than or equal to 0. So when I subtract 5 to the other side, I have x is greater than or equal to negative 5. So drawing this number line, I'd have a closed point at negative 5 and would be shaded above. Okay, so closed point would be up to and including, we use a bracket. So negative 5 would have a bracket because it's a closed point. And then it goes up to positive infinity, and we have parentheses because it's infinity. So infinity is not a finite number. That's why we use the parenthesis. Next, we'll look at number 6. So number 6, we want to see where the overlap is. So 9 minus x squared, this one's a little bit tricky. It has to be greater than or equal to 0. So I'll subtract 9. I have negative x squared is greater than or equal to negative 9. And now I have to divide out this negative 1. So remember, when you multiply or divide by a negative, the sign will flip. So this now is x squared, and instead of greater than, it becomes less than or equal to positive 9. And now I'll take the square root of both sides. So we have x is less than or equal to 3. But remember, when you take the square root, it could be positive or negative for your answer. So since it could be positive or negative, it would be x is less than or equal to 3, and x is, we flip the sign, greater than or equal to -3. So since it's equal to, so for the +3, the sign changes, for +3, the sign stays the same, but for the negative option, we have to flip it. So looking at the number line here, I have 3 and -3, and I'll have a close point here and a close point here. X is less than 3 and x is greater than -3 will be shaded right in between here. Okay, so since this is a fraction, we have to look for the overlap. Okay, so for the denominator, we have x, and x just cannot equal 0 for the denominator. So here we have 0, and for this one, we have an open point, and any number bigger than 0 would work, and any number less than 0 would work. So our overlap here would be right here. That's our overlap. So the way we would write this, -3 up to 0, because we have an open point for 0 here. So -3 has a bracket up to 0. And then 0 has an open point, so I have a parenthesis. And then union, we're going to continue on from 0 all the way to 3. And then that ends with a bracket because it's a closed point. So since it overlaps in this area, we include just the overlap. So there's no overlap here because it's an open point, which is why we need to use union. Okay, last one, number 12, is similar. We have a fraction, and we have to look for the overlap again. So in the numerator, x plus 5 has to be greater than or equal to 0. So I subtract 5 to get x is greater than or equal to -5. All right, so let me get my number line started. I have -5, and this is greater than or equal to, so I have a closed point -5 and shaded above. For the denominator of x minus 1, when we have a radical in the denominator, it still has to be greater than 0, but it would just be greater than 0, would not be equal to, because in the denominator it cannot equal to 0. But since it's a radical, it cannot be negative, so that's why it's just x minus 1 is greater than 0. When I add 1 to the other side, I have x is greater than 1. So here I'll make a mark where 1 is, and I'll have an open point at 1, and it has to be greater than 1. So our overlap is here on. So the overlap, it starts at 1 with an open point, and it goes to infinity. So it didn't overlap over here, so we won't even acknowledge that.